Okay, so here I want to talk about permutations, and these are situations where we are not going to arrange all of the objects. So let's go ahead and set this up here. This first number is going to be the number of objects I have, and they may or may not be unique. And then the second number, R, is going to be the size of the arrangements. Now, we can use this formula. It's just the number factorial, and then we subtract these two numbers. But you've got a calculator, and the button on the calculator is right below the delete button in yellow. And so you can do this pretty easily. In this first one here, you'll notice that we have 1, 2, 3, 4, 5, 6, 7 numbers, but I'm only going to put them in arrangements of 3. So I'm going to do 7p3. And then when I go to the calculator and enter that in, it's going to be 210. In this situation, I still have 7 numbers, 1, 2, 3, 4, 5, 6, 7. However, I'm going to arrange them into arrangements of 3, but there's a duplicate. So just like always, when I'm doing arrangements and there are duplicates, I have to divide by the number of duplicates factorial. And so that's going to give me a different number. That's going to give me 105. So in this case, to make sure we don't have any confusion, the wording is very important. So we're going to say that hearts are only the first 2 of the 5 cards. In restrictions, if there are no restrictions, I have 52 cards and I'm putting them in arrangements of 5. That's going to be 52p5, and you can find the answer to that. In this one, if I have only hearts for the first 2, well, that means I'm going to do my first 2 cards. I've got 13 objects. I'm going to arrange them in groups of 2. Now, the next 3 cards, 1, 2, 3 out of the 5, have to be non-hearts. There are 39 non-hearts, and I'm arranging them in 3s. Now, what's going to happen is to find this answer, I'm going to multiply those 2 together, and I'm going to get the total. In number 3, you'll notice that how many ways can 4 out of 18 girls sit on a 4-seat sofa? So I've got a 4-seat sofa when the oldest girl must be in one of the seats. Now you'll notice it doesn't say which one that she has to be in. So that means there's 4 different places that she could go. She could go here, 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 or here. So there are 4 different ways that this can happen. So we're going to start with that. But let's say the oldest girl is here in one of the arrangements. Well, then there are 17 left, and I'm going to arrange them in 3s. Now, in this situation, there are 17 girls that are going to sit in arrangements of 3 in 3 seats. The oldest girl can sit in one of 4 seats. And there are 4 seats available. So to find this one, I'm going to do 4 times 17p3. Now, in a situation where they have more boys than girls, or girls and boys, and more of one, very often you'll be asked about if they're sitting together or separate. And so first, let's take a look here. And the question is saying, how many ways can 4 boys and 3 girls sit if the girls must be together? All right, if that's the case, I'm going to sit this 1, 2, 3. They're my girls, and they must sit together. And If you want to, we could name them G1, G2, and G3. And now I've got 4 boys, 1, 2, 3, 4. And now we've got to arrange them, all of these groups. Now, again, if you have a situation where any groups, any people need to always be together, what you need to do is first find out the way, put them together next to each other, and then find out the number of ways that they can be arranged. In this case, these can be arranged 3 factorial. Now, the thing is, now count them as one thing. And so I've got 1, 2, 3, 4, 5 things that I'm now arranging. And so I'm going to arrange them times 5 factorial ways. 1, 2, 3, 4, 5. So what's 3 factorial times 5 factorial? You should get 720. Now the thing is, if the girls must be separated, what I do is take the bigger number, in this case they're boys, and the boys will be lined up like this. And there are 4 of them. Now the girls can sit, and I'm not going to put G's because this is not necessarily representing girls, but it's representing where they could sit or where they could stand. Girls could go here, 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 or here. If the girls are in any of those places, then they're going to be separated. So that's where they possibly could stand. Those are the options. So the thing is, though, there aren't that many girls. There are only 3 of them. So first we'll start with the boys. I've got 1, 2, 3, 4 boys. They can be arranged in 4 factorial ways. Now I'm going to work with the girls. There are 1, 2, 3, 4, 5 possible places that the girls can sit in. And the thing is, there are only 3 girls, so clearly I'm only going to actually use 3 of the spots. So now I'm going to multiply those together, and I'm going to get 1,440. All right, so let's look at another one like this. In number 4, it says how many ways can 3 math books and 5 English books be arranged if the math books must be together? All right, now, just because they're math books doesn't mean they're the same math books, so we're going to assume they're not, that you're unique, okay? And problems are going to tell you if they're exactly the same. So here, I'm going to go and set this up where the math books, I've got 3 of them, 1, 2, 3, math 1, math 2, math 3, and they're all together. And then I've got 5 English books, 1, 2, 3, 4, 5. Now, just like I said before, I'm going to take this group and figure out the ways they can be arranged. They can be arranged in 3 factorial. Now, I'm going to multiply that times the ways that all the objects can be arranged, and I'm going to count these 3 things as one object. So now I have 1, 2, 3, 4, let's try that again. 1, 2, 3, 4, 5, 6 objects. So I'm going to multiply times 6 factorial, and I'm going to get 4,320. And again, if you're just copying this, you should be trying to do it, see if you can't do it on your own. So in this case, we're going to try this with the math books being separated. Here, let's do the math books. There are, let's do the English books. So I've got English, 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 and English. And then I've got places where the math books could go. That's here, that's here, that's here, that's here, that's here, and that's here. Now what I want you to do is take a look. It's very similar to the problem that we did before this, which again seems to be number 4. And try to do this, and then pause it and start back up again, and then we'll finish it up. Okay, hopefully you did that. And again, we're going to start with the E's. I've got 1, 2, 3, 4, 5 English books. They can be arranged in 5 factorial ways. I've got spots, 1, 2, 3, 4, 5, 6 spots for the math books, but there are only 3 books that can take up those spots. So what I'm going to do now is multiply those together, and I'm going to get 14,400. All right, let's take a look at number 5. Here, I've got a group of 10 boys and 7 girls. How many ways can the two be chosen out of the group for the parts of villain and hero? All right, so here in this case, it could be 2 girls or there could be 2 boys. All right, so in this case, if I've got 2 girls or 2 boys, then what I'm going to do is I'm going to take the total number of boys, and I'm just going to make this, well, if you think about it, if I've got 10 boys and they can be arranged in 2s. One would be the villain and one would be the hero. One would be the villain, one would be the hero. Hero, villain, villain, hero. If I take the boys and arrange them in 2s, this is going to give me all the ways that I could do this and get 2 boys that are either one is going to be the villain and one's going to be the hero. And I'm going to do the same kind of thing with the girls. That's going to be 7p2. That takes all the 7 girls and arranges them in 2s. And that gives everyone a chance to be the first and everyone a chance to be the second, which means everyone the chance to be the villain and everyone the chance to be the hero. So this meets one of the criteria and this meets the other criteria. So I'm going to take these 2 numbers and I'm going to add them together. And when I do that, I get 132. Now, it's different if what I want is I want to get a boy and a girl. So here, let's say this, that the hero is first and the villain is second. So what I got to do is I got to find out ways to make the boy a villain, and then the boy the hero, and then the girl the villain. And then I've got to reverse it, and I've got to find ways to make the girl the hero and the boy the villain. So what we're going to do is we're going to do first, in this situation, how many ways can I arrange the boys in groups of 1? Well, there's 10p1, and then there is 7p1 girls. And then I'm going to do the exact same thing, only it gets reversed. 7p1 times 10p1. All right? And see, then I'm going to take these 2 numbers and I'm going to add them up. If you get this, you should get 70. This is also going to be 70. There should be altogether 140 ways. And see, another way to think about this is, how many ways can I fill this spot? Well, there are 10 boys. And how many ways can I fill this spot? Well, there are 7 girls. 10 times 7 is 70. And then I just reverse it and I do 7 times 10. And when I'm arranging in groups of 1, it really is just the same thing as saying how many ways can this happen. So now let's take a look at this next one. They love to do these kind of problems where they take words and mess around with them. So first, what I want you to do is I want you to find the number of ways that marmalade can be arranged, rewritten, with no restrictions at all. So pause this and try that, and then start back up again when you get ready. All right, hopefully you did that. So I'm counting the letters. I'm seeing that there are 9 letters. 1, 2, 3, 1, 2, 3, 1, 2, 3. If there are no restrictions, then I'm going to do 9 factorial, but there are definitely duplicates. You'll notice that there are 2 M's, and you'll notice that there are 3 A's. So I'm going to divide it by 2 factorial and 3 factorial, and then I'm going to get a number, and that's going to be the answer. Now, if they want the vowels to be together, well, so I'm going to write all the vowels together. And again, I've already said that there are 3 A's, so let's do that. A, A. And then the other vowel that we have is an E. Now, the rest of the letters, well, they're non-vowels. So I've got M, R, L, D. Now, remember, if I want to put a group together, I'm going to put them together. And now what I'm going to do is find the number of ways that they can be arranged. I'm going to write that here. And then I'm going to multiply it times the number of ways I can arrange all of these items, considering this first group of vowels as one thing. Pause it and try it, and then start back up again. Okay, so hopefully you did that. If I'm going to do these vowels, there are clearly 4 of them, but 3 of them repeat, so that's the number of ways I can arrange the vowels. And now I'm going to multiply it on the number of ways that I can arrange these objects. Here's 1 object, 2, 3, 4, 5, 6 objects. So I'm going to arrange these 6 objects, 6 factorial. However, 2 of them are duplicates, so I've got to divide by 2 factorial. And when I do those 2, I'm going to get a number, and that's the number of the vowels being together. Keep in mind, I've already took an account with these A's being tripled or duplicated in this first time, so I don't have to do it the second time. Now, if the vowels all have to be separated, then what I'm going to do is set up my non-vowels, which would be M, V, nope, not V, not V, M, R, L, and D. M, R, L, D. Now, these are my vowels, the vowels must be separated. So these are the non-vowels. These are the places the vowels could go. They could go here, they could go here, 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 and here. Now, I've got to do is first find the number of ways to arrange the non-vowels. So we've already said there's 1, 2, 3, 4, 5 non-vowels. But the thing is, 2 of them are duplicates. So we're going to divide by that. Now I'm going to multiply by the number of ways that I can arrange these stars. How many? I got 1, 2, 3, 4, 5, 6 places. But I only have 4 vowels. 1, 2, 3, 4. So I'm going to arrange them in 4s. But once again, the problem I have is that there are 3 of the vowels that repeat. So I'm going to divide by 3 factorial. When I multiply those together, I'll get the answer. Taking here at this next one, it says we've got 5 men and 2 women and 4 children. I have a situation where the men have to be in front and the women have to be at the end. Well, so I'm going to have 5 men, 1, 2, 3, 4, 5, and then I'm going to have 4 children, 1, 2, 3, 4, and then I'm going to have 2 women, 1, 2, okay? Now, what I'm going to do then is figure out the number of ways things can be arranged. These guys can be arranged in 5 factorial ways. The children can be arranged in 4 factorial ways. And then the women can be arranged in 2 factorial ways. Now the thing is that in this case, you'll notice that they aren't saying that they have to be together. They're saying that the women or the men have to be in the front, the children have to be in the middle, and the women have to be at the end. So this is the only way these groups get arranged. So all I got to do is multiply those together, and I'm going to get the total number of ways. Now, if I just want the women to be together, well, again, let's put them together. W1, W2. Now, the thing is, then I don't really care about the rest. They are women and men, but all together, there's going to be, or not women and men, they're going to be men and children. All together, there's going to be 9 of them. And so note that I've got 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I'm going to put these together. How many ways can they be arranged? Figure that out. And then count how many things we've got. There's 9 here and 1 more here. And then multiply it times the number of objects we got and how they get arranged. So this is going to be 2 factorial. And then I'm counting this as 1, and these are 9, so this is going to be 10. And then total is going to be the number of ways all that can be arranged. And if the children need to be separated, well, then I'm going to put the non-children, and this is going to be easier. The non-children, I'm just going to call them bars. So the non-children are men and women. I got 7 of them. 1, 2, 3, 4, 5, 6, 7. Those are non-children. And then the children can go in these spots here. So the first thing is that I figure out how many different ways the non-children can be arranged. Well, there are 1, 2, 3, 4, 5, 6, 7 non-children. That's going to be 7 factorial. And then I look for the way that we can arrange these spots where the children can go. And the thing is, I've got 1, 2, 3, 4, 5, 6, 7, 8 places for them to go, but I don't have 8 children. I actually only have 4. So I'm going to put them in arrangements of 4. And when I multiply those 2 things together, I'm going to get this answer. And then here for number 3, if I want to do no restrictions, well, I'm going to take the number of letters, factorial. I'm going to divide by the numbers, the ones that repeat. And you have to be careful because there's several here. The R's repeat, the E's repeat, and the M's repeat. So those are going to be down here. There's going to be something factorial, and something factorial. The R's repeat, the E's repeat, and the M's repeat, or are duplicated. You got to figure out how many, and then put the total. I'll give you the total. The top one's going to be 11 factorial. All right? So now, if I start with an M and I end with an M, okay? So that means I've got to have, altogether, I've got 11 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, if that's there and that's there, all right, there's only one way that happened, because M's are identical, okay? So forget about the M's. I don't have any M's anymore. They're always here and they're always here. So now all I got to worry about are the non-M's. Well, there are 9 non-M's. However, some of them are duplicated. If you recall, the E's are duplicated and the R's are duplicated. And so they're going to go here, and then you get your answer. Now, if the vowels are going to be separated, I'm going to do non-vowels. And there are 1, 2, 3. Let's see, our vowels are going to be E, 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 and A. Those are our vowels. So if I've got 11 letters, that means I've got to have 7 non-vowels. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Those are my non-vowels, and they can be arranged in 7 factorial ways. And then I've got places for the vowels. And I've got more places than I've got vowels, so that's why I'm going to use permutation. I've got 1, 2, 3, 4, 5, 6, 7, 8 places for the vowels, but I've only got 4 vowels. So I'm going to put them here. Now the thing is, what I've got to be careful with is that you'll notice that some of my vowels are duplicates. So now I'm going to have to divide this by 3 factorial. And that's going to give me my answer. All right, so let's take a look at this one. A number between 100 and 99, where each digit is different. Well, keep in mind I got 0 through 9 as digits. And if I'm going to go here, if I take a look here, if the first number has to be 1 through 900, well, there's only 9 ways that can happen. Okay? So there's 9 ways for that to happen. Now keep in mind, I've used one number. There are 10 digits available. So that means I've got 9 digits left, but I'm going to arrange them in 2s. So then I multiply these together because there's 9 ways to fill this first spot, and then there's 9p2 ways to fill in the next 2. If I do the same thing with this one, it's going to be, it has to be odd and greater than 700. All right, so once again, 1, 2, 3. Well, if it's got to be greater than 700, one situation is if I put a 7 here. Another situation is if I put an 8 here. Another situation is if I put a 9 here. Now, there's only one way for me to put a 7 here. And then if I do that, then what happens is that I got to take a look at these odds. And if it has to be odd, there could be a 1, 3, a 5, or a 9. Because I got the 7 up front. So there's 4 ways for that to happen. And see, now I have 10 digits that I could choose from, but there are 8 left. That's one way that I could get this odd number. If it starts with an 8, well, now I can use 1, 3, 5, 7, and 9. So there's 5 ways and 1 way, and again, 8 ways to fill this middle one. And again, for the last one, if there is a first number as a 9, well, there's 1, 3, 5, 7 that I can use. That's 4 different ways I can fill the spot. 1 way I can fill this spot, and then that leaves me 8 digits to fill this spot. So I multiply these together, add them up, and that's going to be the number of ways. All right. So I got to go. I got a class about to come in. So try to see what you can do with these last 2. And if you want, you can email me and ask for some help. All right, thanks.